field, you have the guy that is actually um, 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 the guy who is in the field. You have the guy uh, who is seated somewhere to support the engineers. You have somebody from the factory, which is actually really the highest level to support those particular engineers. So that are kind of places that engineers get some work to do. Generally, I believe that I'm speaking to a lot of students here. Um, generally, um, the most important things that I have come to learn for to be able to work, especially as a service engineer, a field service engineer. Um, Number one thing, you have to understand electrical drawing and schematics. Many equipment in their manuals will have block diagrams of how the thing is connected, and some machines will actually have actual schematics for the particular boards and how they are connected. You need to be able to understand what it means, what a resistor is, how is it connected. You need to understand how to read block diagrams for you to be able to work as a service engineer 100%. Second thing, from my knowledge, or rather from my experience, I have come to learn that it's very, very crucial to understand programming, and for simple reason. Okay, if you understand programming, then you are able to understand how something is being done. If you understand how something is being done, then you are able to repair it. And when I talk about programming, generally I mean hardware programming for embedded systems and also some software under programming. Very, very important from my experience. The number three thing that you definitely really, really need to understand is how to work with Windows operating systems and Linux operating systems. As I told you, all of these systems, they are running on um, operating system level and then application system level. If you do not understand how to work with Windows system, don't understand registry files, don't understand the device managers, how can you really hope to be able to repair the system? For like GCT scanners, all of them are using Linux as a base system. If you don't understand how to read through files in Linux, how to copy files, delete files from the command line, really, you're never really going to be able to repair these systems as a service engineer. So it's very important, even as you are studying, to understand operating systems. The number four thing really is electronics. Um, Basic electronics knowledge is very important because it allows you to test out components. How to use your multimeter for X-ray systems, how to use a signal generator. Sometimes you actually use that. Um, Electronics knowledge is very important and should really, really be taken into a lot of consideration when you're trying to learn all these different things. Definitely, you need a whole host of social skills. As service engineers, one thing to take is every day that the machine is not working, the doctor is losing money. So definitely, if it's not working, they're going to be stressed 100%. So you need to have an way to learn how to speak to the different doctors, whether you're working for an OEM, you're working for yourself, even just as even if you're working for the hospital, you need to understand that every day that the thing is not working, the guy is losing money or the lady is losing money. So once you know that, then you understand why the job comes with a lot of pressure. It's a lot of pressure, crazy, tremendous pressure. But it's because they're losing money every day, the thing is not working, and especially for imaging systems. So those kind of soft skills to communicate with the doctors, with the radiographers, with the management, with your bosses, you need to understand that nobody is trying to be a hard ass to you. It's just that they are stressed because they're losing money. Once you understand that, then you're able to move forward. Um, Next thing that you need to have is skills in technical writing. When you're filling in the service reports, you don't give stories. As engineers, you give a technical report. Technical report means problem, cause, solution, and be able to explain this so that another engineer, when they read your report, they can get a clear idea of what you're talking about. So technical writing and documentation, and then also, of course, problem solving mindset. The number one thing that definitely somebody should always ask themselves whenever you're trying to repair something is, how has it been made? Okay. And as I said, very, very important, read the manual. You need to understand, how has the thing been made. It has this particular problem. Where does this where most likely is this problem coming from before you attempt to repair it? Any repair that you start with just touching things is not actually engineering work. That is not engineering work. Engineering work starts with understand the theory, understand what you're touching. If it works, don't touch it. If it doesn't work, touch it. Yeah. Number one cardinal rule of engineering: if it's working, don't touch it. 100%. If it's working, do not touch it. Okay. And then, of course, um, the other thing is that for us to be able to work multimodality, to work with different manufacturers of different systems, is because we have done trainings. So there are companies in the US and in Europe, pretty sure in India, in China too, that offer vendor specific trainings. So maybe you'll have a training that is focused on a particular system from a particular manufacturer. We've done a lot of trainings, and it's very important that even as you are growing in your career, to definitely work on the trainings, especially if you want to become a service engineer. Um, you know, there is a field service engineer. You have to do the trainings. There's no other way to it. There's no other way to learn about these different systems other than through a training. Um, I now, as the world is moving forward, major trends that are coming up is the use of AI for assisted assisted reading of the images, or rather assisted examinations, um, where you have some examinations that are being done by robotics, or rather not being done by somebody who's actually seated at the hospital. All the patient needs to do is just go in, they're given instructions, from a remote place, and then they're able to make an examination that is coming along. Or rather, you have maybe a CT scan image, requires a doctor to read it. So you're having now AI that is able to actually diagnose problems, maybe of the lungs, especially for tuberculosis, that is very common now, and to give clear indicators of tuberculosis. And even during COVID, that was something that was very, very big. Uh, of course, we have the teleradiology systems, where it's very common in Africa. I don't know whether it's the same in India. But you have very many facilities that have these systems: X-rays, ultrasound, CT scans, everything, but they do not have a resident radiologist that is sitting in the facility. Okay, so the operator of radiology equipment is called a radiographer, and a specialist doctor whose specialization is radiology is called a radiologist. The radiographer makes the image in the machine, or rather controls the machine to create an image, and then the radiologist writes a medical report for it. So radiologists, like in Africa, are very few. So they are not sitting in everywhere you have this thing. So you need a way to transfer that image to the radiologist, have them write a report, and send it back for you to pass it over to the patient, and the patient is able to take to the clinician to get medicine or corrective cure. So you need to be able to transfer those images in such a way that they arrive at the radiologist exactly how they were. It's as if the guy was sitting at the machine, because they are making measurements. The difference between maybe 1 millimeter and 3 millimeters is maybe stage 1 and stage 2 cancer. So it needs to be very, very exact. And for that particular case is what we have the PACS systems and the teleradiology, where you're able to send images of what we call the DICOM standard to the radiologist. They arrive there exactly the same as they were on the machine, is able to write a report and send them back. So that's actually something that is coming up along a lot, and definitely much very important. And of course, with some systems now, especially for OEM, they come with a particular module where a service engineer that is seated at the factory or in the office for the company is able to perform remote diagnostics for the system and preemptively order parts before even they arrive to the site. So that's a great trend. Works a lot. Almost all OEMs, if they have a service contract with a particular client, will be able to do this. It hasn't yet come into our independent service organizations, but hopefully one day that works. Oh, okay. So I think I just went a little bit above the amount of time, but that's my presentation for now. And I'm open to any questions that anybody might have or other wish another. I'd like to pass it over back to you um, um, to lead the rest of the process. Thank you very much, and much appreciation for all of you that have been able to join and for the discussion that we've been able to have. Thank you.